Okay, we've got the combinatorics review. So we started off with the fundamental counting principle. If we have A objects of one type, B objects of another, and C objects of another, we simply multiply the different number of options we have to figure out the total number of options. We can be using factorial notation with the exclamation mark. In the top right hand corner, do not forget logic. There's going to be totally different ways to do these different questions. We want to be able to practice in different ways and start to see which ways we like the best and be comfortable going back and forth between the two. Guess and check, obviously a great method for this. Just figure out what all the different combinations are, write them all down as like a guess to see how the formula works. Blanks. Blank times blank times blank, using the fundamental counting principle. In those blanks, we're going to put the number of options on the top and the actual options that we have below for notation. Big things to consider. In the given information, are we allowed repeats? Are we going to replace? If we take a card out, do we replace that card with another card or not? Do we replace it back in the deck, shuffle it, and then take out another card or not? Lots of times we're going to be timesing by 2 or dividing by 2 or timesing some number. We might be changing the order just by rearranging the way you look at it. Tree diagrams, drawing the tree diagram, seen a couple times. Using the formula outcomes per trial to the exponent number of trials. Remember, when using tree diagrams, we multiply within the branches and add the leaves. Don't forget all minus none, or the ways you cannot do something, or all the ways you can, all the ways you can do it, minus the ways that you can do that thing that you cannot. Remember cases. We're going to multiply within cases and add separate cases. Be aware of the formula. When we have identical objects, we just take the total number of identical objects, dividing by the number of on the top, factorial, over the number of repeating letters factorial, repeating letters factorial. There's an interesting formula with a circle, n minus 1 factorial. We'll get there at some point. Combinatorics formulas, always making sure that n is greater than or equal to r. We have permutations when order matters, and we use this formula, and combinations when order doesn't matter, using this formula. Remembering that NCR is just NPR divided by R factorial, seen in the present example. We'll be doing the binomial theorem. We'll be doing paths in squares, very similar to identical objects. Possibly paths in cubes, probably not. And then using the binomial expansion formula with this given information, remembering there's n plus 1 terms, and k is always 1 less than the term number, and we can find any term in expansion without having to expand it. And don't forget, probability is just the number of ways that we can choose a desired outcome out of the total number of outcomes. We're not going to see as much probability until we get to university. So again, combinatorics, it's a very interesting chapter where there's so many different ways that we can do the same thing. And you want to be really comfortable being able to use different methods for the same question or vice versa, etc. A lot more university-like thinking, and that's why they put it last in Pre-Calc 12. Hopefully it doesn't count towards your university mark, but if it does, this one's a real one. This one obviously is really important to do well on.